Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 4 from chapter 7, which is talking about reciprocal functions. So recall from the last chapter that the reciprocal of a number is 1 over that number. So say our number was 2, the reciprocal would be 1 over 2. So the reciprocal of a function f of x would be 1 over f of x. So say, for example, our function was y is equal to x. So x here would be our function, so our reciprocal function would be 1 over x. And looking at this graph here, we actually have the graph of the base or the original function y is equal to x and the inverse function y is equal to 1 over x. So if you look here, this blue straight diagonal line here is our original function y is equal to x. And then these two red curved lines here are the the reciprocal function. So there is actually a relationship between the graph of its original function and the reciprocal function. And we can talk about this in the table below. And for the most part, for any type of reciprocal function and the original function, they will follow similar types of characteristics, but they won't be exact. So if we're looking at the domain and range of our original function and the reciprocal function, we would notice that for y is equal to x, your x values can basically be anything. So there's no restrictions on your x values, but with your inverse function, here we have that x cannot equal to 0, but it can be anything else. So looking up here at this graph, at our original function, you would see that it continues on and on in a straight line. So there's no restrictions on x here. But in terms of our reciprocal function, we would see that our red line approaches that y-axis, or where x is equal to 0, but it never actually crosses it. So we would say that x cannot equal to 0. Looking at the range, that's looking at the spread of your y values, so what y can and cannot be. Very similar thing happens here. So y could be anything in our original function, but in the reciprocal function, y cannot equal 0. So let's take a look at that in that graph. So here we can look at the spread of our y values on our original function. And you could say that there's no breaks in the graph. If we were to continue it on and on forever, we would notice that y could be anything. But what we do notice about our reciprocal function is that as we're approaching y is equal to 0, or that x-axis, we would notice that these red lines, or the reciprocal function, never actually touches or crosses that x-axis. So there we say that y cannot equal 0. When we're looking at the end behavior of our graphs, this part here is very important for when we are trying to graph the reciprocal function. So looking at our original function, when we take the absolute value of our x value, we would also notice that the absolute value of y is also very large. So say, for example, we were to take the absolute value of 8, or negative 8 here. So if the absolute value of 8, if we would consider 8 a large number, then your y value is going to be large here as well. So this one here would be, say, negative 8, and this one here would be negative 8 as well. So those absolute values will both be larger values. So then looking at our reciprocal function, here if the absolute value of x is very large, then y greater than 0 is close to 0. So this here essentially says that y is approaching the horizontal and vertical asymptotes. And if you've never heard of the word asymptote, this here just means that this is like a line that your graph does not touch or cross. Okay, so looking up, we can look at our graph here. So here when we're looking at our graph, we have actually two asymptotes here. And so the first one here is where y cannot equal 0, And now when there is a horizontal asymptote, and we usually indicate that using dashed lines. I also have a vertical asymptote when x is equal to 0. So a vertical asymptote at x is equal to 0, and a horizontal asymptote at y is equal to 0. Now this here is very important, because as you notice, as we're going up, so as we're approaching that x-axis or that y-axis, we're approaching that value, but it'll never actually touch. Same thing as we're going down to the right, we're going to be approaching that y-axis, or that x-axis, sorry, but it never actually crosses or touches it. Same thing below our x-axis. We'll approach each of those horizontal and vertical asymptotes, but it never actually touches or crosses it. And that there is going to be very important for when we're graphing. So look at the behavior at x is equal to 0, which is at y-axis. Here we would say that y is equal to 0 in our original function. So that they're saying that we're at our, that is at the origin, so at 0, 0. But for our reciprocal function, this here is undefined. And you can even tell when x is equal to 0, if you were to flip that value, you have 1 over 0, and that doesn't make sense. You can't divide a number by 0, so that's why we say it's undefined, and that tells you that we have an asymptote at x is equal to 0. The last thing that we can look at are something called invariant points, and invariant points do not change from your original graph to your reciprocal. So that's at y is equal to 1 and y is equal to negative 1. Because if you were to look at, say, the reciprocal of 1, we have 1 over 1, which is just equal to 1. And the reciprocal of negative 1 is 1 over negative 1, which is still equal to negative 1. So those ones do not change regardless if you're working with the original function or your reciprocal function. This one here is also very important when we're graphing. So looking here, if you were to draw both of your graphs on the same graph, you'll notice here it's where their intersection points are. So it's at 1 and positive 1, and negative 1 and negative 1. So you should typically, with a linear function, so when your original graph is a straight line, you should only have 2 invariant points. So those are just some important characteristics that we need to know in order to graph reciprocal functions. So now we're going to move on to example number 1C from your notes, where we're actually going to graph the original function and its reciprocal. So here we're going to consider the function f of x is equal to 2x plus 5, and we're going to graph the function and its reciprocal. So whenever we're graphing the function and its reciprocal function, you're always going to start off by graphing, or at least finding the table values for your original function. So y is equal to 2x plus 5. And one thing I need to caution you about, whenever we're trying to graph the reciprocal, we need to show those invariant points. So we need to see in our table values when y is equal to negative 1 and when y is equal to 1. Everything else, not so important, but we need to see those invariant points. Very important. So that you can either figure out by setting y equal to negative 1 and solving for x, or you can use that logic and think what value for x would give me negative 1. So I'm actually going to do the work just down here at the bottom. So down here we're going to set y equal to negative 1 and solve. So we have negative 1 is equal to 2x plus 5. When I'm solving for x here, I first need to get rid of that adding and subtracting. So here we have plus 5, so I'm going to minus 5 on each side to give me negative 6 is equal to 2x. Then I want to get rid of this 2, so I'm going to divide. by 2 on each side. And so I would find that my x value is equal to -3. And I can put that x value up into my table values. Then I want to find out when y is equal to 1. So I'm going to do the exact same thing here. So I'm going to set y is equal to 1 and solve for x. So this is basically the exact same work. So here I have +5, so I'm going to subtract 5 to give me -4 is equal to 2x. Then I'm going to divide by 2 on each side to give me x is equal to -2. So we have -3 and -2 in our graph, or in our table values. So the next thing that we need to do is I'm going to choose at least one more value from my table values just to make sure that my graph creates a nice straight line. So I might want to go with 2 points that are in between -2 and -3. So I might go with -2.5. So here I'm going to set x is equal to -2.5 and solve for y. So here y is equal to 2 times -2.5 plus 5. So 2 times -2.5 will give me -5 plus 5. And so here I would get y is equal to 0. So I try and have at least 3 points in my graph just to make sure I haven't made any errors in doing any of my work here. So if I have 3 points on my graph that create a straight line, then this means there's a good chance I haven't made any errors in my work. So in order to graph your reciprocal function, I'm going to show you a method where you use the original function and do or complete the graph based on that original function. So we actually don't need to create a table of values for our reciprocal function. And I'm actually running out of time for this video, so I'm actually going to stop here and we're going to actually graph this function in the next video.